Hi guys, today we're going to talk about the scientific method, which should be much of a review for you. Because I love you, I'm going to review it anyway. Enjoy! So before we talk about the scientific method, first we need to know what science exactly is. In its most basic definition, science is using evidence to learn about the natural world. The goals of science are to deal only with the natural world, to collect and organize this information, and then propose explanations that can be tested. So that's our great lead-in right there. All science begins with observations, and an observation is as simple as collecting data using your senses. And we have 5 senses. I'll wait for it. Okay, you got them. 1, touch. 2, hearing. 3, sight. 4, sound. And 5, taste. So those are all your senses, and you use them all the time to collect data, whether you realize you're doing it or not. You're a scientist, and you didn't even know it. So data is just characterized as information gathered from observations. Okay, so there's 2 types of data that we talk about in science. Quantitative data. Quantity. So this is a number. So the example I gave you is 5 dogs. 10 students, 1 teacher. Anything number or numerical is quantitative data. Qualitative data is where we're talking about a quality of something. So it's going to be descriptive. What kind of qualities? Is it, large, small, brown, black, white, red, blue, so on and so forth. Oh, hey, look, we're going to do this, but in a different way. From those observations, it leads us to form inferences. And an inference is a logical interpretation based on prior knowledge or experience. So you're kind of interpreting based on something that you've seen happen. It's not something that you've tested per se. Alright, so you see a window broken and a baseball's on the floor next to the shattered glass. You can infer that baseball broke your window. Okay, you guys make Facebook inferences all the time. When you see people in the same pictures, you're inferring that they're friends, although no one's come out and said, hey, I'm your friend, or I'm their friend, so on and so forth. So a hypothesis is a proposed scientific explanation, and it is testable. That is the most important thing about a hypothesis, that it be testable and can be confirmed with further experimentation or observation. Observation in itself can serve as an experiment. I know, super cool. Alright, and now the lovely and beautiful scientific method. Our first step is to ask a question. Will my tomato plant grow better in the dirt at my house or in potting soil? I'm going to gather information. So I'm going to do some research about this topic, about tomato plants growing in ground soil versus potting soil, and see what I come up with. I'm going to do a controlled experiment to test my hypothesis, and then I'm going to analyze my data and basically look at the numbers, put it in a beautiful little graph, and then draw a conclusion. And then the last step is to communicate your results. You want to tell people what you learned, because it could be a breakthrough, major breakthrough. Alright, so we're going to go more into depth into controlled experiments. So in an experiment, there's several variables that you need to be aware of. And these are, again, review. We have the independent variable, or the IV, because I change it. Okay? And that is the variable that's deliberately changed. So placing the tomato plant in either the potting soil or in the ground at my house. The dependent variable is the variable that responds and observes. So that would be our tomato growth. A control group is the comparison group without any treatment, and it allows the experimenter to compare the test results. So in this case, since I'm not adding treatment to something, then there will not be a set control. Alright, but if I was testing like levels of caffeine or something on the plant, then I would say 0 caffeine, 1 milligram, 2 milligrams, and the 0 is the control group. So constants are factors that are kept the same and not allowed to change. Like the tomato seeds, they came from the same pack. It's the same species of tomato. The tomato plants are put in the same amount of sunlight, receive the same amount of water every day, so on and so forth. And this is super important because if you don't control all of these factors, then you can't interpret your data and attribute it to just the soil factor. Alright, and lastly, you need to repeat the experiment, and it's typically done 3 times, but it reduces the possibility of chance errors affecting the results. Now, if I was going to put my data into a graph, which of course I would do, a title, the effect of the independent variable on the dependent variable. And if you remember, the independent variable is, so the effect of potting soil versus ground. Nice Pocosin ground. Whoop whoop. On the growth of tomato. Yeah, that's not too pretty, but you get the idea. So the independent variable is always on the x-axis. Always, always, always. It's the one on the bottom. The dependent variable is on the y-axis. So in this case, I would probably do a bar graph with the height. And then here's the 2 different tomato types. Cool. Oh my god, it's beautiful. Good job, Warwick. And from our graph, you would be able to tell that the beautiful Pocosin ground was much better than the potting soil. Yeah, so it grew more in the Pocosin soil than in the potting soil. But you wouldn't say that on the graph. You'd say that in the next section. Just to go over a few types of graphs, this is a bar graph used to compare categories of things. This is your independent variable on your x-axis, dependent variable on the y-axis. Here's a line graph. It's used to see change over time. So time in this case is our independent variable, and millions of people who switched from AT&T to MCI is our dependent variable. So we're looking for a change over time. And it looks like that it increased over time, which makes sense because really MCI is like not around anymore. And lastly, we have our pie chart, which is used to show percentages. So you guys, you know, the whole thing is worth 100%. You get the idea. So last but not least is the difference between a theory and a law, because you'll see these a lot when you hear stuff about science. So a theory is an accepted explanation that unifies a range of observations. It is a well-supported hypothesis, and it could have been changed over time or modified. So the theory of continental drift, evolution, people add on to these theories. It's generally accepted, okay? A law is a statement of fact meant to describe an action. It's very, very well supported through experimentation, like the law of gravity. So the difference here, a theory is like how nature works, and a law is what nature does under certain circumstances. So they're talking about 2 different things.